Enclosed area. Let's begin with what is enclosed area. Enclosed area is an area between two curves. Look at the graph shown on the screen. The highlighted area is what we are going to calculate. Let's get to know the formula. Definite integral. The formula composed of the integral, a. the lower limit of integration, b. the upper limit of integration, the integrands, and a variable of integration. The area will always be area under the curve, approaching y or x-axis. For the first example, we have to find the area of the regions in the first quadrant, which is red line below the graph of y equals to square root of x, but above the graph of y equals to x squared. Since there is no specific intervals, we have to find the point of intersection first, by equating the two equations together. After we got the intervals, we can move on to calculate the actual area by using definite integral formula. Substitute a and b with 0 and 1. In this graph, what we are going to use at f of x substitution is the red function, square root of x, and the substitution for g of x is x squared. Then simplify both equations and integrate them. After that, substitute the intervals into the antiderivatives. To calculate it by using y-axis rather than x-axis, you should try tilting the graph before you decide what axis you are going to use. Again, this problem doesn't provide you the intersection point, so it is necessary to find it by equating the two functions and solve them. After you get the intersection point, you must solve the function for x in terms of y, because this time the area is approaching y-axis instead of x-axis. Then, use y intervals to substitute a and b instead, which is -1 to 3. For the integrands, the function f of x should be -y squared plus 10, and the function g of x should be square of the y subtracted by 2. Next, calculate the area using integration. We need to calculate the area above and below x-axis separately, because if you calculate like you would normally do by using the top function and subtracted by the bottom one, it will give you the net area, because the area below x-axis is negative. Therefore, you need to multiply -1 at the end to the area under the x-axis to get the positive result. Also, you need to multiply the integrated function by 2 because you calculate it by half. Lastly, add the area of each side of the axis together to get the total area.
This video was illustrated and voiced over by Nathamon Jungwathana, and the editor is Shalisa Det Anand. Thank you so much for watching till the end.